GigaMe instructor live sessions. Today we take a session on monolithic versus microservices architecture.
Hello.
Hello. Then first we'll go through all the microservice concepts one by one. Then we'll go through the caching concepts. See, if you are familiar with the REST API design, the microservice is little bit when you basically separate the each service in let's say separate folder, or means you are creating separate services for each functionality. Let's say login service. Okay, payment service. Then notification service. Earlier we used to write all code in single code base, right? So if you make
I don't have idea on earlier how it used to be, but as you mentioned now, I used to write services, REST services for login, for registration separate service, for editing the profile separate service, for login separate service, and for the
yes, yes.
main
So
functionality.
let's say you return the login service and registration service. So after means login service and registration service were in same folder, in same code base, right?
Same code base in the sense, same repository.
Yeah. So now nowadays what is happening? Look, let me open stat.
Sorry, excuse me. I mean, separately in the same code base in the sense, same
No,
repository.
separately in the sense we have different project for each service. Let me show you. Close. Here, if I go, let's say this is our project name is project name is e-commerce project. Okay, inside e-commerce project we'll create let's say login. Inside login we'll create, let's say, register. Okay, so e-commerce is a common project. Inside that we have login, register, and payment. So when we deploy, we'll deploy basically e-commerce application. It means when we deploy e-commerce, it will auto deploy these all three components, right? Now, nowadays, what is microservices? Microservice means you will create single service at each project. So I'll create one login service is one project, means I will deploy it independently. Then I will create register service as a new project, and I will deploy it as a independently. Then I will create payment service independently. Payment service I will create independently. Okay. So payment service is also one microservice that I will deploy it independently. Now, what is advantage of using these microservice based architecture is, let's say you are good in Python, so you can develop the login service in Python. If you're good in .NET, you can develop the register service in .NET. If you're good in Java, you can develop the payment service in Java. So means multiple team can work on same project with a different repository. Making sense now? What is microservice?
Can you repeat the last sentence? What do you mean by multiple team?
No, come again.
Multiple team can work on same project.
Let's say I have 10 team members, 10 team members, and in 10 team members, I found like some are good in Python, some are good in .NET, some are good in Java. Okay. So instead of developing using single technology, what I'll do is I will assign login service to Python team. Means Python service will develop the login service module. .NET team will develop the register service module. Java team will develop the payment service module. So independent technology we can choose, and we can develop the application because these applications are independent. So you can just deploy it. Okay.
Okay.
That's the advantage of microservice-based architecture. Means we have different tech stack. We are free to choose any tech stack. But earlier in this earlier called monolith architecture. In monolith architecture, you have to write in using single tech stack. Let's say you are good in Python, so you have to develop everything in Python only. Okay. And let's say you change in login module, but instead of you have to deploy complete application itself. Okay. Even if you make a small change in payment service, you have to deploy each, means all project together again. But in this case, in this microservice architecture, this is not a case. If you change in login service, you will only deploy login service. Okay. If you make change in register service, you will only deploy register service. That's it. If you deploy register service, it won't affect your payment service. But maybe in Monolith architecture, this was a challenge, right? Let's say if I deploy login and something wrong happened with login, then my other two code will also not work because this will get blocked here only. But in Monolith, it's not, in Microservice, it's not a case. If your login service is not working, still your registration and payment will work. Clear hai microservices now?
Yeah, just one question. Like,
Yeah.
let's say in a let's say I've developed a web services.
Hmm.
Let's say in Python, by utilizing the Python frameworks like Django,
Hmm.
MVC architecture, I have created one project and created one project in Django, and I have developed the web services for login, register, and payment in a
Yes, yes.
single code base. Then it comes under monolith architecture, right? Uh, am I correct?
Yeah, yeah. No,
So
yeah, go ahead, go ahead.
So in that case, let's say I have done some changes. Let's say I've done some changes to login service, and I've deployed the project. So again, the register and payment service will also get deployed, even if there are no any other changes, right?
Yes,
Uh,
yes, yes.
so in that, if there are some issues with the login service, then like as the register and payment services are working, let's say there is some issue with the payment service, but
Hmm.
there are no issues with login and register service. Then why the login and register service will get impacted if there are any issues with the payment service? I didn't get that point.
See, what is happening is this. Understand, this is a one single kind of project. How in Java, let's say, or in Python, if you write any function, let's say you have three functions, and if you get error in main function itself, how your other function will not execute, right?
Let's say it's not something related to code, like uh, there is no some issues related to code, but I mean there are no like 500s in there, 500 issues.
Hmm.
So in that case, the application will work fine, right? If there
Yes,
is
yes.
some,
In that case, it's
there
fine.
is some
Yes, in
fix-
that case, fine. That case, so totally fine. Because your login endpoint is not working, that doesn't make like register will not work. But what I'm telling you, let's say if you deploy e-commerce application and your e-commerce server is down, then how you'll make the login, register, and payment, right?
Okay. You mean to tell like the entire if the entire let's say now login, register, and payment are running on single server.
Yes,
Uh, the server went e-commerce server went down so that all the three gateways won't work. When
yes.
it comes to
Because
monolith,
because this is the disadvantage of Monolith. In Monolith, if you deploy the because in Monolith you will deploy e-commerce project, right? In e-commerce, let's say something wrong happened with the e-commerce server, then these three will not work, right? But here it is not a case. Here each service is a separate server. Login service is deployed on separate server. Register service is deployed on separate server. Payment service is deployed on different server. Okay. So if something wrong happened with this server, but still these two server will run, yes or no?
yes.
That's what this is relevant. So now that's why nowadays people prefer to use microservice-based architecture. And if you go in this documentation as well, just read it. They have written very well here. Yes. Designing a scalable backend. Now see, exploring monolith versus microservice architecture. So in software architecture, the debate between monolith and microservices approaches has been ongoing. Monolith architecture are traditional, where all components of an applications are tightly integrated into a single code base, while microservice architecture decompose the application into smaller, independently And deployable service means each service is a deployable service. You can deploy those services. So now, what is monolith? Monolith architecture have been the go-to choice for many years. Yes, earlier there was no choice. There's people used to write code in monolith architecture itself due to their simplicity and ease of development. However, the application grow in complexity and scale. Monolith architecture starts showing limitations. These limitations often includes scalability. Monolith application scale as a single unit only, meaning all components must be scaled together, even if only one part require more resources. This can lead to inefficient resource allocation, right? Now, second is maintainability. With all components tightly coupled, because all components are tightly coupled, which are dependent on each other. Making changes to one part of the application can have unintended consequences of other parts. This makes maintenance and updates challenging, especially as the code base grows. Then we have deployment complexity. Deploying updates to monolith applications require deploying the entire application. Even if only a small part has changed, this can lead to longer deployment time and increase risk of errors, right? Then next challenge is technology diversity. Monolith applications often use a single technology stack, so limiting of flexibility in choosing the best tool and technology for each component of the application. So these are limitations of what? Monolith application. Now it's clear?
Yes.
Now coming to microservice architecture, microservices architecture address these challenges basically by breaking the application into smaller, more manageable services. Each service is responsible for a specific business function. I mean, each service which you deploy or which you write or develop, those basically meets the business function clearly. It means if I am developing the payment service, microservice, payment service will only handle the payment related thing. Payment service will not focus on how to get users and how to display users and all. No. So each service is responsible for a specific business function and can be developed, deployed, and scaled independently. This brings several benefits. What are those benefits? So first benefits in scalability means you can scale your application at any point of time. What is scaling? Microservices allow for fine-grained scalability where only the parts of the application that requires more resources can be scaled. So either you can do horizontal scaling or you can do vertical scaling. Vertical scaling means when you increase the same service server, like it's a RAM, ROM, whatever you want to increase it. Horizontal scaling means you are putting multiple servers. Clear hai? Horizontal scaling, vertical scaling?
Yes, I have bit idea on horizontal and vertical scaling.
Okay. Then we have modularity, with services decoupled from each other. So changes to one service do not affect others, making one code base easier to maintain and update. Because you will only change, let's say in login service, so you will only focus on deployment of login service. Other service will be remain same. Then deployment flexibility, same thing. Microservices can be deployed independently, allowing for faster and more frequent updates. This enables organization to adopt continuous integration and continuous deployment practices, leading to faster time to market and improved agility. Yes, nowadays people follow the agile. So to improve the agility, people are focusing on the microservice-based architecture because they like using microservices architecture, CI/CD make this process very smoother, okay? Because of continuous integration and continuous deployment. And then we have technology diversity here. Each microservice can use the most appropriate technology stack for its specific requirement. This allows organization to leverage the best tool and technology for each service, leading to improved performance, scalability, and resilience. So overall, it's written clearly, while monolith architecture have their place, microservice architecture offer greater scalability, flexibility, and maintainability, making them an attractive choice of modern complex applications. So these are the architecture difference.
Okay.
So here the exploring the architecture of a Spring Boot, you can read about the Python, how you'll achieve with the Python through Python, okay, technology, okay.
Sorry,
Concept
your
is same. Concept is same. Only code is to syntax and will change in your case. So key principles and guiding the design of Spring Boot microservices system include decomposition, service autonomy, resilience, API first design, and containerization. Yes, orchestration tool we have to follow Kubernetes for deployment, and then Docker for containerization. Because using this Docker and Kubernetes, it will be very easy to handle the microservices deployment and CI/CD, basically integration and deployment.
okay.
So that's why if you are moving through microservices, then you have to learn the design pattern of microservices, like how we can change monolith to microservices, and then you should have some small amount of knowledge on the Kubernetes and Docker side. If you are handling in some companies, DevOps team is different. So DevOps team mostly focus on these two. Okay. But as a developer also, we should know how to create container, how to create config file, how to set up the project on Kubernetes. And then from there Kubernetes, we can easily, scale our microservices container. The container which you create on Docker. So basically these are orchestration tool. Automatically things will happen. See here. The tools like Kubernetes are commonly used to manage and orchestrate the deployment, scaling, and monitoring of microservices in distributed environments. This is very important. To start with microservice, it's not directly you can jump on microservice and you'll create single. No. First, you have to decompose your applications into smaller, more manageable service based on business capabilities. I am giving you simple example. Let's say I have one e-commerce application or where we have 3 users, use customer, vendors, and admin. Okay. So for admin, we'll create separate microservice, admin management. The admin management can only handle the creation of users and creation of vendors, right? Similarly, if I have vendor application, I'll create separate vendor management where the vendor can upload their products, vendor can create the products, edit the products, set the price, set the quantity, everything can do by vendors. And for customer, we have separate customer management where customer can search the products, view the products, and make an order, see the order history, those functionalities. So microservices should be decomposed in a smaller entity, but you have to think like what are your business requirements. Based on the business domain only, you can decompose your services. So here, building scalable and modular application with Spring Boot. See, user service, manage user authentication, registration, profile management, product service, handle product catalog, inventory management, and product related operations. Order service, responsible for order management, processing, notification service, and gateway service. Yeah, so in microservice, you need one API gateway. That is called gateway service. Why you need API gateway? Because let's say, any idea about API gateway? What is API gateway?
Uh, I had an idea about AWS API gateway
It's same
service.
thing. Either it's an AWS API gateway, either you create your own API gateway through code. It's same thing. Concept wise both same now, because in AWS also if you create API gateway, that API gateway will redirect your endpoint to other servers or other API, right? Here also same thing. You will create one API gateway service, which will basically expose the route of each service. Let's say for login service, URL is local host colon 5000/login, like this. And for this, let's say local host colon 6000/register. Let's say register. And for this local host, let's say 7000. So inside the API gateway, we have listed all these routes. So, and we'll expose one common route, something like this. API .com, let's say something. So frontend will call api.com/ here login, and now API gateway will redirect this api.com login to localhost 5000 login service. It's job for API gateway. So API gateway is basically application programming interface entry point gateway, because API gateway only knows how to redirect the routes. At same time, API gateway not only redirects, API gateway can transform the request object and transform the response object also. If you want to, let's say, display different data on different client, let's say in mobile, I want to display different data, and on desktop, I want to display different data. So these response data transformation and request data transformation easily done by API gateway. So API, read about API gateway, it's an entry point. And let me show you here also somewhere should be there. Let's say this one. They're also written in our site. There. See here, we have client-side code. Client is talking to API gateway first. Then API gateway will react to service 1, service 2, service 3, service 4, service 5. See here, from this is the entry point here.
Okay.
So it's clear. The API gateway we aiming to build will have two main job. The filtering and routing agent will manage request routing based on the filtering procedures. A series of filters will determine if the request should be forwarded to the backend services, redirected, or even rejected, whatever. Then we have security agent is one of the filters that perform a more through examination of the authentication and authorization here. So this is just a thing they have written in Spring Boot, how to create like different services. Some parts are missing here. How to create a high performant API gateway using Python.
First, we have to know how to create microservices using Python.
Yes. Yes, you can read these blogs for creating the services and Yes, for microservices, what need to do is we have to implement the token-based authentication layer for security, for securing of our microservices endpoints. So you can read these blogs if you get time. So to be good in microservice, we have to learn these techniques, these things. Okay, go with Spring Boot, no Spring Boot, let's say Python framework, Flask, then service registry, a gateway, distributed configuration in Python, load balancer, circuit breaker, tracing, then message broker like Kafka or Apache, RabbitMQ, containerization like Docker, container organization like Kubernetes, RESTful APIs, and authentication and authorizations. So these are the topic you can replace with your Python technology to be good in microservice design pattern. Then you can know like what is service discovery of works. Eureka is service registry for resilient mid-tier load balancing and for failover. Service registry basically discover those services from one common service. Okay, service registry themselves with Eureka and the service you can find them Eureka server side components. So Eureka is third-party tool. You have to work with Eureka to create the service registry. Then you see API gateway using Spring Cloud gateway. You can create using Python also. You can create. Then we have need configuration management where we all have configuration should be stored. Then we need circuit breaker. If let's say something happened wrong, so we need the fallback message from the services. This is called circuit breaker. So you have to implement the circuit breaker concepts as well. You'll find this documentation from Python also. There are lots of nowadays in market people developing the microservice architecture only. Here we can read about HCE, an API gateway. Already I explained you crucial component in modern microservice architecture. It's accessing point for clients to access various microservice, handling tasks such as routing, load balancing, authentication, authorization, rate limiting, and more. API gateway like Spring Cloud Gateway and Netflix Joule are popular choices in Java ecosystems. Similar thing, you can search for Python, how to create API gateway, how to create login service, how to create tracer service. Then you need some configuration file. I mean, distributed configuration with Spring Cloud config. In your case, it will be different. So why we need configuration file? We have to create config servers. Basically, distributed configuration with Spring Cloud to manage and distribute the properties for applications across different environments. Let's say we have production environment, development environment, and QA environment. How regarding these three environments, I say the configuration among all the services. For this, you have to create one common configuration service server. Inside that server, you will mention all the configuration related things. Like this. Name my app, UI, HTTP, config, HTTP. Like this, you have to. Then load balancing. How to balance the load for each service. In load balancing, when you deploy the application, that time in AWS, configure the load balancer, right?
Yeah.
To balance the routes for different service. If loads increase, how the load balancer will redirect those routes to other services or other server. In Spring Cloud environment ecosystem, Hystrix is popular circuit breaker tools. The message broker we need because how to communicate with multiple services. Let's say I have one microservice user service and one is login service. How user service will connect to login service? Let's say login successfully done or something failure. So in this case, for asynchronous communication, we need the message broker like Kafka. You have to integrate the Kafka. So if something you want to execute or something you want to send the notification, through message broker only you can send a notification, because notification could be a synchronous call. How will manage the synchronous call? So read about the Apache Kafka and RabbitMQ. You have to create the message consumer and producer server in your code. So whenever you, let's say something payment done. So after payment done, you will push the message inside the Apache Kafka consumer or Apache Kafka producers. Then consumer will receive those messages from the queue, like something payment done successfully. That's why you will see in real time also you are getting notification later. Once you make the payment, after some time you will get notification, right? Like payment done successfully, because these are placed in the queue. Whenever queue is free, and they are sending notification to us through RabbitMQ and Apache Kafka. So you have to read about what is producer, what is Apache Kafka cluster, what is consumer. Consumer means those components which basically consuming the messages from the Kafka topics and processing them. Producer means the component responsible for producing the messages and sending them to Kafka topics. That's why. That is simple thing, but configuration is a little bit difficult. In I don't know in how to implement in Python, but in Java it's very much familiar. So what do go and create today? Simple thing you can do it. Like if you have any existing project now, it's a simple project itself. Create two service, one for user service. Create two services in Python, one for user service and one for, let's say, auth service. Auth service will only handle login, sign up, forget password, okay, these things, okay. And user service will only handle get users list, delete users list, edit users list. Create two microservices today and run these two microservices independently in your local system. Try to practice with in a small level. Just start with the Python for now, creating microservices without integrating the API gateway or load balancer for now. When we jump on API gateway load balancer, then we integrate those two technology as well. Yeah,
Okay,
to
for now,
developing these microservices, you need the concept of REST API design. I think you already know this REST API.
yeah. So you want me to develop two microservices for use microservices named user service and auth service, and where users in Python. So in the user service must should be able to handle the get user requests and delete users and edit users, and
Yes.
when it comes to auth service, using this auth service, we should be able to log in into the application, and we should give the sign up functionality, and we have to give the forgot password functionality. So you want me to develop microservices using both the you want using the Python, right?
Yes. Yes. Try to practice a small level. Yeah, in Python.
So once I'm done with that, we have to work with the API gateway part, right?
Yes. Once you're done with that, then I will show you how to create API gateway and how you can create load balancers as well.
Okay.
API gateway will create, then we'll create the config server, then we'll create like a what? History server for circuit breaker, I mean.
Mm-hmm.
So let's say why circuit breaker? Let's say this auth service is failed, right? So we need some message to end users, right? We'll display something fallback message.
Okay.
And yeah, in here also, later when we learn the caching, we have to implement the caching mechanism as well. Because let's say I'm calling the get user first time. Second time, if I call get users, it should not go to DV. It should fetch data from the cache, right?
Yes.
So then we'll implement gradually caching service in our all microservices pattern.
Okay. What is the config service? What does it does?
Config server is here. It is central place to manage the configuration. Configuration could be, let's say you are developing application in local system. It is called development mode, right?
Okay.
In development mode, let's say we have DV port is different. DV port is, let's say 900. DV password is something different. DV user is something different. But when you deploy the application, then we have production mode. Yes or no? In production mode, we have different DB port, different DB URL, different DB passwords. So all these configuration I will store in one common config server. So based on the environment, orchestration tool will easily pick this data. So if you are running in local, it will connect your local database. If you're running in live server, it will connect with your live database. Clear hai?
Okay.
So for this, we need the config server management. That's it. Where not only this configuration, where you can write secret key also. Let's say secret key.
Just 1 minute. Just can you please repeat once again the config server part?
See, config server is here used to manage the configuration at global level. When I say global level, it means, let's say for user service, if I use any database, so in local, database will be different. Like in local, you will connect to MySQL, which port and password is something test and test2. But in production environment, the database URL will be different, right? It's a RDS instance from the AWS, something. Clear? How then your application will connect those database frequently? If I am running local, it should connect in local environment. If I run in production, it should connect with production environment. So how? So who will handle this information? Who will keep this information? So we have to create separate config server which will keep this information.
Okay.
So you can read about the configuration management here as well. Something written here. Configuration management Spring Cloud Config, in your case, will be different. Spring Cloud Config provides server and client-side support for externalized configuration in distributed system. It supports a variety of sources, retrieving configuration properties.
Okay. What do you mean by distributed systems?
Distributed system is what? We have different systems which are placed on different environments. This is called distributed, right? Distributed means what? Let's say user service is running on something, let's say 12.34.56 IP address, and then slash of login here on this server only. Your register service is running on some other IP 12.56.78.90, right? And again, this user service is scaled on different multiple sub servers. This is called distributed, right?
Okay. Here it's nothing but deploying the services in different servers.
What is what is minimum distributed? Distributed means things are distributed on the network, on the cloud, right?
Okay.
Even each server, user service, user server, auth server, notification server. Then how in distributed you will manage the configuration? If I have single server, let's say single code base, I can easily manage. But user service is running on different server. This is running on different server. Then who will tell to user service that you have to pick this database? Who will tell?
Config server.
So in this case, you need to create config server management. That's it. Simple.
Okay.
First, do one thing. Go through this. I know this is written in Spring Boot and Java, but you can easily refer those topics in Python as well. It's something not it's a huge demand in market. So you will easily get all the documentation of Python also. Okay.
Okay.
Then start with this like a small level. Start with these two service first and see you have to run both server to get the data. You have to run user server also, and you have to run auth service also. And check with Postman. Are you able to perform those operations or not through Postman one by one?
Okay. So what is the difference between microservices and REST APIs?
No difference. See, microservices is a pattern of your I mean, it's the architecture pattern. REST inside this user service, you only create REST API only.
Got it. It's like a microservice is the architecture of the application.
Yes,
Uh, is just the architecture of the applications. We use the REST API concept for creating the
but yeah. Sure. But the root
yeah.
level will be one independent service, I mean.
Yeah, we have two types of architectures like monolith architecture and microservice architecture.
Correct. Correct.
In both the architecture, we use the same REST
Hmm.
APIs, right?
Yes.
For communication. It's just
Yeah,
independent thing. Microservice is the independent thing, and when it comes to monolith, it's all combined thing.
correct. Yes.
And web services and then REST APIs are both the same name, or what is there any difference?
No, come again.
Web services in the sense.
Yeah, web services in the sense, see, in web services, earlier people used to term, see, REST APIs are called stateless thing. I mean, see, what
Got
is REST?
break. You got break. Please repeat. You just broke.
See, REST API are called what? Representational state transfer protocol. When you develop the REST API, it means it's a stateless protocols which run on HTTP.
Okay.
Stateless now means server will not maintain any data for you on that side. Server will not store any state for you. Right? In web services, people used to write the pattern through SOAP and other things, where data exchange can happen through XML format. In REST API, you can choose the JSON format.
Okay. Here, web services and REST APIs. In the REST APIs, we can give the JSON format, and when it comes to web services, it's the XML format like SOAP, right?
Yes, and important about REST API is REST API is stateless, means when you perform the REST API, you have to handle something token based authentication mechanism, because these are stateless protocol. You do, server don't, user service don't know who you are, right?
Okay.
So you have to tell to user service, hey, I have this token. So please decrypt my token and then get the information from DB and get the information about me. Who am I? Like, let's say I'm an admin or I'm a user or I'm a test user, whatever.
Okay.
But in earlier, people used to develop the web services where the server maintains the session for you, right?
Okay.
So when you log in, server will create one session and that same session, it will keep persist until unless you don't log out from the application. Okay.
Okay.
But nowadays, this is not a case. Logout is totally independent from the backend. If you log out, client side will destroy your token. So for next request, if there is no token in the backend, then backend will know like you are not authorized user or not authenticated user. Simply, you need some token to pass the. You have to pass token to backend. Simple.
Okay, let's say I have to pass the token in JSON format to the REST API in order to utilize, uh, in order to, let's say if I'm using Postman
Hmm.
and I'm calling a REST API,
Hmm.
in that case, I have to definitely pass the token. Otherwise, it won't give me the response, right?
Not for first call. I mean, what I mean, yeah, for user service you have to pass. Let's say for auth service, for login, why you'll pass? For login, you don't need token. Login is just a public API. If you log in successfully, then only you will get token from the backend, right?
Okay, utilizing that token, it gives us the other functionalities.
Correct. To
Uh,
use, yes. Let's say I want to get users. In get users call, I have to pass token, because if token is valid, then only I will get the users from the database. Otherwise, I won't get. So simply
okay,
think things how works is, let's say this is our login page. Okay. So user will go to login page. Once he log in, server will send one token to him. Let's say token is 123. Okay. Token is 123. Now let's say I'm calling users API. I will call users API and I will pass some tokens to backend. Then backend will receive this token and decrypt it and validate with the decrypted data. If it is 123, then it will allow to enter into the user service. Otherwise, it will throw the error 403 error. You don't have authorized to see this users list. Think
Okay.
like token system is a restaurant. Okay, how you enter in restaurant? First, you are getting the token, right? After
Yes.
getting token only, you are making an order to the waiter and all. Otherwise, you won't. If I have token mechanism, right?
Yeah.
Same thing here also. Server don't know who you are. Even restaurant owner also don't know who you are. He will only know if you get the token from the restaurant.
Okay.
Clear hai? So read
Yes.
about this authentication mechanism using delivery token will and how to implement token in microservice-based architecture. Mechanism. So important in microservices. Just read about monolith first, microservice first, how to get architecture, what are the things required for microservices, API, load balancer, circuit breaker. Those first read it in detail. How to implement token, how to implement database as well. Sometimes people prefer to use single database. Sometimes people use to write a multiple database configuration. For login service, different database. Register service, different database kind of.
Okay.
So read about this, the how database should be like. There are multiple things in microservice. Not in one session I can explain you each details.
Okay.
We have the pattern like saga pattern, orchestration pattern, how the commit and rollback will happen in microservice. These are very important. Transaction is very important topic in microservice. Why transaction is important? Let's say you have one order service and you have payment service. If I place an order and then payment should be done, and let's say payment failed, in some case payment failed, then how you'll roll back the order service microservices code or code, no, not even code, mean data, which is saved in database. So transaction management is very important topic in microservice architecture.
Okay.
So in transaction, basically you have to read about saga pattern, orchestration pattern. You can read one book. Let me here. You can read this book. Chris Richardson. Everything in this side is only microservice related topic. Nothing new. All are microservices. See the architecture is clearly written. Saga pattern. You have to learn it from here. Transactional messaging. External API, service discovery, liabilities. Everything is clearly written. Okay. This one from this book. Okay, then let's meet on next session. Okay.
Yeah, sure.
Sure. Thank you.
Yeah. What do you want me to do by the next session?
First, read about microservices and create something and test with Postman.
Okay.
Small level. Then read the other topic like API gateway, load balancer, caching, transaction, database creation, authentication. There are multiple topics in microservices.
Okay.
First, start with at least how to create microservice, how to run microservices, test with are you able to get small like data or not. Okay.
Oh, sure.
Yeah. Thank you.
Thanks a lot.
Thanks for watching. Want to stay updated and learn more? Follow us on social media.